Hello students, welcome to the next lecture on the PY questions on real analysis. Today we will discuss about all those questions from the part C related to the year December 2011 to 23. Myself Dr. Harish. You can simply scan and join my WhatsApp group here. Otherwise you can simply follow my YouTube channel Dr. Harish, where you will find the playlist CSIR UGC net, where you can find the PY questions of the complex analysis from the year 11 to 23. Markov chain real analysis of the complete part B, linear algebra, as well as the many more in this complete playlist, partial differential, ordinary differential, statistics and many more. So let's start with this video. So remember, this is the part C, so more than one correct option in this all questions. Look at that, this is the question from the year December 2013. So before solving the question, you have to think about what the option exactly told to you. So remember, this is this is the integration of there, and you have to find the bound. How you can find the bound? Look at that, the two integrals are from the pi by 2 and one is from the here. What is that? Integration is from 0 to 1. So clearly says that 1 plus x raised to power 8 is always be greater than or equal to 1. But we here all needs strictly, so I can written like of here. Then 1 over 1 plus x raised to power 8 is always be less than 1. Then you can integrate over this 0 to 1. So what is the integration of this is 1, and this is my L. So L is my strictly less than 1 is the first right answer. Now you can think about the pi by 4. Can you think about any of the term which involve the pi by 4? That is of the tan inverse of 1, because my limit is 1. So what is the which term you can think about that? That is the integration of just like say here. So I have to find the relation between x square and x cube. So you can see x square is always be greater than of the x8 whenever x lies between 0 and 1. Fine. Then you almost know that if you adding 1 on the both side, you can write like here. And if you write of this, which is less than of this case, then you can integrate on the both side over this limit 0 to 1. So this is my tan inverse x from 0 to 1, which is less than of the L. So L is greater than of the pi by 4 is my right answer of this problem. So the A and D are my correct answer. Okay, look at this next question. M and N are any of the real numbers. P and Q, which of the following are my correct? So let's think about the P less than Q. P and Q. This is a term same. This is the same, so we don't focus on this. And we all know supremum is always be greater than of the infimum. So what is the meaning of that? Q is always be greater than of the P. So the first option is the correct. R is less than equal to S. Here supremum and supremum, they both are same. So again we can see S is greater than of the R, because supremum is greater than of the infimum. Q is less than of the R. So how you can say Q is less than of the R? So we can think about the Q and R. This is infimum, this is supremum. This is supremum, this is infimum. So there is no relation between Q and R. Q may be greater than, Q may be less than. So it is always cancel out. P and S, supremum, infimum. Supremum, infimum. So we all know supremum is always be greater than of the infimum. So S is always be greater than of the P. So this is the right answer. So A, B and D are my correct answer. So you can see without solving, you can easily solve the problems. Okay, look at this question. This is from the year 2014. So f is any continuous differentiable function such that here. So you can think any of the function which is continuously differentiable. So like say 1, which is a constant. You can think as easier as much as possible. So then what is my L? So L is, this is my 1, this is my 0. So limit of them is my 1, and it's satisfied here. If you think about that, a function which is continuously differentiable like a polynomial, then what is my L? L is my infinity, so which is not lies here. So you can't think about here. So L is my 1. Now you can think about that. If limit f dash, what is the f dash is exists, that's 2, it is 0. Fine. If f dash exists, limit of this exists and is equal to L. L is my 1, this is fine. If limit exists, that's fine, the limit will be 0. But what is the limit of the fx is my 1, which is not equal to 1. So this option is cancelled out. This is fine. What is the limit of the f dash? So f dash will be my 0. So this portion is my 0. What is the L? L I obtained as a 1, which is not same. So this option is cancelled out. These two are the right answer of this problem. Look at this concept. F is the mapping from Rn to Rn, which is defined like of this: x norm of x square for all x is in the Rn. Now remember, as I told you in the PY question of the linear algebra, PY question of the complex analysis, what is that? It is true for all these Rn. So I can simply take n is 1. What will happen? The mapping is from R to R such that, what is that? This is norm of x in the real line is only x. So this is my x cube. Fine. Then look at that. D of f. D is my derivative. So what is the derivative of this? 3x square. Now d of f 0 is 0. That's correct statement. D of f of x. What is the d f of x? This is it 0 for all x is in the R? No. If I take x is my 1 by 2, then clearly says d of this is my non-zero. So this option is cancelled out. F is 1 1. How you prove that 1 1? So you can see x cube is always be 1 1. So otherwise you can simply draw the graph of this. How you can prove the 1 1? If you draw the horizontal line, if it cuts only the single point, like as I mentioned you in earlier, if I say this is my y is equal to x square, if I draw the horizontal line, it cuts at the 2 point on the curve. So it means this is not 1 1. Now you can see if you draw like here, it is again cut it at a single point. So it means this is my 1 1. F has an inverse. When it will be the inverse? When it is a 1 1 and on 2. So we already proved that it's a 1 1. How you can prove that on 2? If you draw the vertical line, it cuts only at the single point. You can see at a single point. Similarly, if I draw from here, it again cut at the single point. So this means this is the onto, this is a 1 1, it's a bijective, so inverse existence. So that's a simple answer of this. Remember, when nothing is given to you, you can prove that for as much simple as you can. Okay, look at this next question. This is given to your partial derivatives. You have to discuss about their directional derivative and so on. That's very simple. What is that? Firstly, I will tell you the simple shortcut tips. If fx, fy, because they are the fx and fy, are exist and continuous. If partial derivative and exist and continues for all the x in my domain, whatever the domain is there, then what is the meaning of that? This implies f is differentiable at all the points on the domain. That's the first remark. Second, you are talking about the directional derivative. So what is the meaning of that? If f is differentiable at point, that it means the directional derivative exists at all the points. That's the simple remark for you. So you can see the directional derivative exists in all the direction everywhere. That's a correct statement from this shortcut tips. F has a derivative at all the points. F has a derivative at all the points. That's also the correct statement. F has a directional derivative only along this point. Because of this only, it's a cancel out. Because it is existence for all. F does not has a directional derivative. That's cancel out. Because this is my polynomial. Every polynomial is my continuous. So partial derivative exists and the continuous here. So the right answer is A and B are my correct options. Okay, now remember, whenever there is a question of the limit and the summation, whatever the summation is given to you, then your target is to always write in terms of the 1 by n. How you write this in terms of the 1 by n? If I take the numerator n square as a common, then it will be 1 by n. This is my here term. Fine. Now once you are writing here, then you can write in terms of the integration. So how you can write the integration? Put x is equal to k by n. What is the dx? 1 by n of dk. So this is 1 over here. Take the limit. When k is equal to 0, x is my 0. When k is equal to n, when k is n, then limit will be and take the limit as n approaches infinity. So it will be my 1. For example, if this is my 2n minus 1, then what will be n? As n approaches infinity, it will be my 2, then it will be 2. But here this is n only, so it is my 1. So what is the integration of this? Tan inverse, that is my pi by 4 is the right answer. Remember, always write in terms of 1 by n. Okay, look at this sequence. Series is given to you from k and l are from 0 to n, k square, xk, and y of l divided by l factorial. So look at the option, which of the following is the convergent. Very simple. If I simply firstly take x is 1, y is equal to 1, what will be my series? K square over l factorial. K and l both are 0 to n, and n is my infinity. So here, so I can write this term as k square separate and 1 by l factorial separate. This is the limit from l to infinity. So clearly says that this is my divergent, because this is nothing but my summation of the n square. So it is divergent. So it means wherever x is equal to 1, y is equal to 1 is a divergent. So this is, it belongs x is equal to 1, this option cancel. This also belongs x and y, so both options are cancelled out. Now look at here. So I can see this option k square. I can write this as a k square x raised to power k as a separate from k is equal to 0 to infinity, and this is y raised to power l over l factorial. L is 0 to infinity. So what is that? This is nothing but exponential of the y, which is convergent for all the values of the y. Fine. And this, when it will be the convergent, you can see we can find the radius of the convergence. So that is 1 over limit an raised to power 1 by n. So limit k square raised to power 1 by x. So it's a 1. So r is my 1. So it means this is convergent when it is less than 1, because equality is a divergence. So what is the option is? When x is my here and y is in the r. So x is in here, this is also the part of the r, this is also the part of the r. So the right answer is A and C are the correct options. Okay, which of the following functions are the limit n here? So what is the tips for you? We all know limit infimum of the function, which is same as that of the limit of this of the fx of this fx, and it is same as that of the f as x approaches 0 or x approaches a, simply a, if I call as a, when, if it exists. Fine. So that's a simple tips for you. Now you can see a function is given to you as a sin x and sin 1 by x. They all are talking about the 0. So what is the limit as x approaches 0 of the f? Sin 0 is 0. This is a bounded function between -1 to 1. Answer is 0. So it means it exists. Once this limit exists, then we can say the lower limit and the upper limits are same. These are less than. Lower limit and same, and both are equal to the 0. So this is the right option, this is the cancel. So A and D are my correct options. Okay, look at that. PAN is a polynomial of this kind, B of nx, with the sequence of the quadratic polynomial an and bn are my real numbers. Lambda 0 and 1 are my distinct non-zeros real numbers. Fine. Then which of the following is existence about that? Okay, that's a very simple. Remember these tips. If fx is a polynomial of degree n and alpha and beta, or instead of the alpha beta, if f is polynomial of degree n and there exist n distinct roots, if there exists n distinct root, then limit of this polynomial fx and limit of this polynomial f dash exist for all the x in the domain. That's a simple shortcut tips for you. Now in this case, what is given to you in this case? Fx, there's a Pn, is a degree. What is the degree? Is my 2. So how many roots we need? 2 distinct root, and they are given to you as a 2 distinct roots. Fine. So what is the meaning of that? Limit as n approaches infinity, polynomial Pnx and limit P dash nx both exist for all those x in the R. So you can see the first two options are directly correct. Now look at that. Here, remember, what is that? Lambda 0 and lambda 1s are in the real lines, distinct non-zero real numbers. So what is the meaning of that? This is also in the real numbers. So what is that? It is existence for all the x. It means Pnx of this must exist, but he said does not exist. So cancel out derivative, because this is also a real number. It said for all those x in the R, but he said does not exist. Again cancel out. Answers are A and B are the right options. So remember, this is a simple tips, you can simply remember it, which is for the any polynomial of degree n. Okay, look at this another question. P and x is there and then so on. Okay, so there are the two functions. I call this is f1, this is f2. We are discuss about the continuous and the differentiability. Look at that. 3x, 2y, y square, x square, all are my polynomials, and every polynomial is my continuous and differentiable. Another thing is mod of xy. This is my continuous. So it means f1 is my continuous, f2 is my continuous. So f1 and f2 continuous, so it means f is my continuous. So this point is cancelled out. Now whether it's a differentiable or not, so this is continuous as well as differentiable. We need to check only that is a mod of xy is a differentiable or not. So how we can check that? We all know we can use this function of the several variable formula, minus in journal it is AB. It is nothing but my say firstly I can write in the journal form. This is A partial derivative x, B partial derivative y, plus a function of the h and k and here or here. So what is that? A and B are my 0, 0. So this is f of xy minus f of 0, 0. Okay, fine, and so on. So another way I can write this as a h comma k, f of 0, 0. You can see this as a 0, 0 is 0. I can write this instead of here. Fine, this is a function of h comma k. Now if I prove that, what is the h comma k is? Of this divided by h square plus k square, which is phi of h comma k. Now our target is to prove whether this limit exists or not. So what we will do? H approaches 0, k approaches 0. Clearly says that what is the degree of the numerator? Degree of the numerator is 2. Degree of the denominator is 1. So degree of the numerator is greater than of this. So definitely it will goes to the 0 as h approaches 0, k approaches 0. Otherwise, you can simply take the path as m is equal to k is equal to mh. Again, you will prove that, but there is no need. Once the degree of the numerator is greater than of the degree of denominator, this will always goes to the 0. So what is the meaning of that? Limit exists. It means it is my differentiable. So that is mod of xy is my differentiable. So this is differentiable. This is differentiable. All are my differentiable. So f is my differentiable. F is not differentiable. Cancel out. This is correct option. Now last option is you need to check whether it is my invertible or not, differentiable matrix. So look at that, at the point 0, 0. How you can find? So partial derivative f1 with respect to x, partial derivative f1 with respect to y, f2 with respect to x, and f2 with respect to y. So with respect to x, 3. This is my at the point 0, 0, it will be the 0, so it is only 3. With respect to y, only 2. This is 2, this is 3. Now what is the determinant of this? 9 minus 4, which is non-zero. So it is a invertible, is the right answer of this problem. Look at the next one. What is given to you? A function f from Rm to Rm is given. Again, you can simply take m is my 1 if you want. That's a very simple task for you. Now look at that. How you can solve this question? D of f. So whenever you have a mapping, what is the D of f? It is always be a linear transformation like of this matrix. Whatever the function, you can write like of this is my df. You can write this is always a linear transformation. Now D of f, so I simply take any of the value, like D of f is 0 for always. Is it true? 0 is all for all the u. It is not true. If I simply take matrix like of this 1 1 0 1, so like makes x plus y and y. Fine. So what is the D of f? This is 1 1 0 1. So it is independent of the x and y. So D of f 0 is my here. Can this be a 0 if I multiply this by any of the u, say x comma y? Is it 0 for all? It not be 0. You can simply take x is my 1, y is my 1. It is non-zero. So it is for all to all. It is a cancel out. Look at the second case. D of x is 0 and some x is in here only if f is constant. So look at that. For some x, you can see I can choose some of the x from here. If I consider the one example like of this, like x plus y, then my D of f is my 1 1 1 1, which is independent of the x and y. So if I choose the one number like of -1, this is my u, then clearly say it will be 0. But this function is my not a constant. He said if this satisfied, only if f is a constant is a cancel out. Okay, if this is, if he said for all the x, if he said for all the x, so what is the meaning of that? If this function is 0 for all x, definitely it will be a constant. If f is not a constant, what is the meaning of f is not a constant? So I can consider the same example here, x plus y, then df is 1 to 1. How you can prove that df is 1 to 1? We all know linear transformation is 1 to 1 if and only if the determinant of this is my non-zero. But you can see from here that determinant of this is my 0. Fine. So what is the meaning of that? What is that? If it is not 0, then it is my not 1 1. So it means this option is cancel out, because f is not a constant. This is not a constant function, but we still will get as a df will be a 0. So there is a correct option only as a C is my right answer. Now this is for some. This is for some. No, it is not for all. It is for only some. So it may happens that if I consider this example like x plus y and y here, then we may get some of the x and y which will be a non-zero, because for the sum x. So I can consider this, and this is again a non-constant function. So yes, this is the right answer. If he said for all, then it is not a right answer. Okay, look at this function is there, and again you have to find the determinant. So that's again, if I first consider as x, second as a y, then f2 by x and f2 by y. So how you can write the derivative with respect to x? So it is 1 plus x plus y of whole square. How you can write this function with respect to y? I can take as a product rule. This is minus y over 1 plus x of whole square. I can differentiate this with respect to x. So firstly I can take this part, and then I can write this as of here, and with respect to y it will be x plus y of whole square of negative. So what is that? I can write this as, I can write denominator simply a, it's a square. I can take as a square as a LCM. So it is 1 plus x plus y, so it is 1 plus x. I can take here as a is a complete LCM. It is a 1 plus x plus y, so it's a 1 plus y. It is minus x over a square. So now the determinant of this, what is the determinant of this? If you find the determinant, it will be my xy over a raised to power 4 minus 1 plus x plus y plus xy over a raised to power 4. So it is minus 1 plus x plus y over a raised to power 4. 1 a raised to power 4 will be cancelled out. So it will be here. Now it does not vanish. When it will be vanish? When x plus y will be minus 1, but that is not in the domain. So it means this will not be a 0. So first option is the correct option. F is infinitely differentiable. How you can check that? So see this part, or you can see this part. If you prove that both are infinitely differentiable, then they are differentiable. X and y are is in the real. So all these ratio are in the Q, and we all know once it is in the Q, what is the meaning of that? They are infinitely differentiable. Fine. So once they are infinitely differentiable, it means F is my infinitely differentiable. So this is also the correct option. Now look at this next option, that is whether F is 1 1 or not. So how you can prove that F is 1 1? So that's very simple. If I simply take x comma y is say my a comma b. Fine. So how you can prove? Oh, that's very simple. Otherwise, as we discussed that if this is non-zero, then we can say this is my 1 1. That is the corresponding function transformation is my 1 1, and we already proved that this is my non-zero for the domain. So it is a 1. Now look at the last option, whether f of a is r square. F of a is my r square. So how you can prove that? I think that's a very simple. How you can think about that? If I see, can any pair of this a has the image in the r square? No. If I consider x is my minus half, y is my minus half, that point is not in the A. So what is the meaning of that? The corresponding image is not in my R square. That means this point not map on the R square. So it means every point of the A, that is the image is not be in there. So this will not be the right answer of this problem. Okay, again this is the similar case, differentiable derivative, and here if I quickly find the derivative of this 1 1 y x, f is not differentiable at the point 0 0. So how you can see that? So firstly you can see x plus y and xy both are my polynomial, which is a continuous as well as differentiable for all those x comma y pair in the R square. So f is not differentiable is a cancel out. Derivative of f is invertible. So what is the derivative is? It is invertible only when x is not equal to y, except on the set x is equal to y is the correct option. Inverse image of the each point has at most 2 points. So how you can find the inverse image? If I consider this as my say a comma b, what is the meaning of that? X plus y is my a, xy is my b. So what is the meaning of the sum of the root is a? I can return this number as of here. So what is the meaning of that? Lambda is in quadratic whose roots are, what are the roots? X and y. So how many points are there? At most 2 roots. If they are distinct, if they are equal, then they are equal. So at the most 2 elements corresponding to the each point is the right answer. Whether is a onto or not. So how you can check whether it's a onto? So we have to find for each inverse image of this, that is, so we can see about that. This equation, what is the discriminant? This one. So if this number is my negative, then we are unable to find the roots like of this. Fine. Or you can say if my a is 1, b is 1. So if I consider this image f of x comma y is my 1 comma 1, then you are unable to find the pair of x and y whose image will be 1 comma 1. So it means this is my not on. Okay, now whenever you are talking about the limit infimum and supremum, then you have to find the firstly limit. What is the limit as n approaches infinity of 1 by n? is a 0, that's a singleton, so singleton itself a supremum, it's itself a infimum, so 0 is equal to 0, satisfied. Whenever there is a -1 is there, so you can break always in the two parts, n is even, n is odd. When n is even, it will be my plus, when n is odd, it will be my minus b. Fine. Now take the limits as n approaches infinity. What is my answer? It is +1, -1. +1 is my supremum, this is my infimum. So 1 is minus of -1, satisfied. This is also right answer. Again, when n is my even, it is +1 by n. When n is odd, it is -1 by n. Then take limit as n approaches infinity, 1 and 1. So both are supremum and infimum. So 1 is equal to -1, not satisfied. Enumeration points of this, any point in this I can return like of this, -1, 2 plus. How I write this point? Like of this or 1 minus of this. So what is the limit point? If I take the limit as n approaches infinity, it will goes to the -1 comma +1. So this is my supremum, this is my infimum, and clearly say that it satisfied. This is also the right answer of the problem. Okay, look at this. S is given to be here. S is the limit point. Firstly, we discuss about the limit point. Okay, so firstly we can n and nx are the fixed point because we need a m and n. So take limit as p tends to infinity of the s. What will happen? This part will goes to the 0. So it is my m. What will happen if I take q as my infinity? What will happen? This part will be 0. So it is my m comma n. Fine, where m and n are here. If I take m is my infinity, what will happen? This is infinity, this is n is infinity is here. So what is the meaning of that? The first, this option is the correct one. The set of the limit point p and q are infinity, it is my here. Now you can check whether s is discrete or not. That's again a very simple. You can, because I can take p and q as much simple as you can. P and q are 0. So what is my s? This is m plus 1, n plus 1. Fine. Now what is that? If I called a and b, what is that? If m is in the integer, then m plus 1 is also in the integer. So a is my integer, b is also in the integer. So what is the meaning of that? Can you conclude any of things here? So it means z here, a and b are in the z, but z is my countable. So if z is my countable, so s is my countable. Is it a discrete? Countably discrete is the, sorry, is a discountable, is a discrete in the R square is a cancel out. So here, now s complement is connected or not. Now here is the tips for you. Whenever you are working on the Rn, n must be greater than of the 1. If you take s is the subset of the Rn, here n is my greater than 1. If you prove that s is my countable, it implies s is my path connected. Remember, these tips were only applicable when n is greater than 1. So we prove z is my countable, the corresponding s is my countable. And we are working on the R2. S is my countable, it means s is my path connected. So here he said it's not a path connected, it's a cancel. So the right options are second and the fourth option. Okay, look at this. This similar kind of the question we already discussed in the previous June papers. What is my Q1? You can see Q1 is my 0.1. Q2 is my 1001. Q3 is my 0.1001, 401, and so on. Now you can observe that these are decimal numbers. Are they terminating? They are not. Are they repeating itself? Like if I say 0.3333, they are repeating after some decimal. 1/5, they are terminating. But here they are non-terminating. So these are non-repeating decimal expansion. It is given to you. Fine. It is a non-repeating decimal expansion. What is the meaning of that? Any of the sequence which corresponding to the non-repeating is always convergent to irrational number. Irrational because they are non-terminating. Once you find that it's a terminating, like of the here, this is a complete terminating, then it converges to the rational number. But it is a non-repeating, non-terminating, so it's a irrational number. So once the sequence is bounded, so how you can check about the bounded? Sequence is my convergent. From here, what is the meaning of that? The sequence is bounded as well. Every convergent sequence is a bounded. So it is a bounded, that's correct. It's convergent in the Q, that's wrong. Q is my rational, but we need a irrational. The sequence is not bounded, so cancel out. The sequence is bounded, that's true, but not a Cauchy. Now how you can check about the Cauchy? Remember, whenever you are working in the R, and we all know Cauchy sequence implies convergent sequence. But if you consider any of the subset of the R, remember any of the subset of the R, and if this sequence of the subset is convergent, then it implies Cauchy. Remember, this result is applicable only for the subset of the R, while converse need not true. Fine. So what is that? Can you find this is a Q? So this is convergent to the irrational number, and this irrational number is a subset of the R. So this Q, that is irrational number, sequence of this irrational number is, we already proved that it's a convergent. So once it's a convergent, it means it is my Cauchy as well. So this is the bounded, yes, it's a Cauchy, yes, but not convergent in the Q, yes, because it convergent in the irrational number, but not a Cauchy. Cancel out. Right option is only 1 is the correct option. Okay, let F be the sequence such that limit of this exists. Limit exists. So definitely look at that. X will not be the function because it's from 0 to infinity. 1 plus x square will not be the function. Sin x will not be the function. The only function where infinity will be defined, like of e raised to power x, e raised to power minus x, or 1 plus x square, because the integration will be tan inverse x, it is well defined. Now if limit f of x exists, limit f infinity, it does not exist for here. Fine. So it means here limit infinity exists, then the limit will be 0. That's a correct statement. The limit f must exist, but here it is not true. Is it satisfied? E raised to power x from infinity? No, it is not a finite, but he said it exists. So this function will not be exist. So limit must exist, correct. Limit must exist, correct. And it is a 0, yes, it is 0, correct. F is a non-negative. This is also the increasing function. This is also the positive function. Both are positive. Limit must exist, that's correct, and it's a 0, that's also the correct. F is a differentiable function, so if I take the differentiable of this, then limit of the f dash must exist, yes, correct. 0, correct. Infinity will be 0, so all are my correct option of this example. Okay, look at this next question. F is a continuously differentiable function such that this is given to you. A and B are the two consecutive zeros of the f. What is the meaning of that? If I hear A and B, at this point f is 0, at this point f is 0. Which of the following are necessary true? Okay, if g of A is my greater than 0. What is the g of A? You can see g of A is f dash A plus iota f of A, but f of A is my 0, so it is here. What is the meaning of that? F is my increasing function. So at this point the graph will be like of upside. It's increasing. So but f is my 0 at this point, so after some time it must be a decreasing. After some time it must be decreasing because f is my 0 at here. So it means f is my increasing. So then G crosses the real. So F, what is the F of this? F of A is my 0. So G, F dash is nothing but my G, or you can see here G is my, okay, fine. Then if G crosses the real, so it crosses from the, it is from my lower to upper, it is from my lower to upper, and then upper to the lower. So you can see it is upper to the lower. G crosses the real lines from lower to upper, and then lower is the right answer. Look at this third option. G of A, G of B is my non-zero. It means F of A, what is the G of B? F of B is my non-zero. It means F of A is my non-zero, F of B is my non-zero. It means F of A is either greater than 0 or less than 0. So what will happen? We all know at this point F is 0, at this point F is 0. If F dash will be my greater than 0 at this point. So since F is 0, so it will be here. What is the slope at this point? F dash at the point B must be less than 0. Here is my greater than 0. On the reverse side, if this is my less than 0, F dash at the point A less than 0, then we must be reaching at the point B. So at this point it must be so greater than 0. It means F dash A, F dash B are of opposite sign. What is the F dash of A? G of A, G of B, opposite sign is the right answer. This is the wrong option. Okay. Pn is the prime numbers, is the increasing order, Sn is my here. So what is my prime numbers? 2, 3, 5, 7, 11, 13, 17 and so on. So you can define this the set as there is a consecutive difference 1, 2, 2, 4, 2, 4 and so on. Fine. Then you have to find the supremum, limit supremum, infimum are here. What is the infimum of the S? 1. Supremum of the S? Infinity. That's a correct statement. Infimum is less than finite, 1 is less than infinity, correct. Infimum of the S is 1. Infimum is less than, both are correct statement. Now limit supremum of the Sn. Limit supremum. What is the meaning of that? That is infimum of the supremum of the Sn. So how you can find that? That's a very simple. Firstly, find the supremum of this infinity. Fine. Then you can discard this option. First element, find the supremum of the remaining element, again infinity. Remove this element, find the supremum of this infinity and so on. So what is the infimum of this? Infinity. So that's also the correct option. Then how you find the limit of the infimum? That's the definition of the supremum of the infimum of the Sn. So that is supremum of. Firstly, find the infimum of this 1. Then discard the first element. What is the infimum of this? 2. Discard this element. What is the infimum of this? 2. Discard this element. Infimum 2. Discard this element. You will get 4. Discard this element. You will get 4 and so on. That will be there. Now what will be the supremum? So definitely supremum will not be a 1 because you get a 2. Supremum will not. So what is the meaning of that? Supremum will be greater than or equal to 2, because if supremum will be 4, then is 4 is greater than 2. Supremum will be 6. If exists, then it's greater than 2. If it is infinity, then again it's satisfied. So all are my correct option of this exam. Okay, look at this next question, which is given to you here. A function is my here fx fy such that limit fx is my 1. So what is that? This is additive to the productivity, additivity to the multiplicity. So what kind of the function will be here? The only kind of the function is my here. That is the only function which satisfies this property, additive to the multiplicity. So now we can check whether x0 is 0, satisfied, satisfied, satisfied. All are here. Then we will check whether f is my strictly increasing. If I consider here, what is my derivative? Which is my decreasing. So this option is cancelled out. f is either a constant or a bounded. F is either a constant or bounded, but you see this function is a unbounded. If I consider this as say my 2 of x, it satisfied all this property, which is my unbounded function. But he said constant or a bounded is a cancel. Look at this function f of rx. If I consider any of the function like of this, what is the rx? E raised to power rx. I can consider this as e raised to power x. It is f of x of r. If I consider e raised to power minus x, it is e raised to power minus r. I can return this number as again of this. If I consider a raised to power x, then it is a raised to power x over r. Again it is my here. So this is my correct option. F of x is greater than or equal to 0. Clearly sees that exponential is always be greater than 0. This is also be a greater than 0. So all 3 and the 4, that's a C and D, are my correct answer of this problem. Okay, look at this one. Which of the following is my uncountable? Remember always, Q is my countable. Okay, Z is my countable. R is my uncountable. So you think about on the R. Collection of all those pairs from the R2 such that A is less than B. So what is the nature of the A and B? They are in the R, and R is my uncountable. The first element is my uncountable. Second pair, you consider A and B belong to the R such that the sum will be in the Q. But what is the how many A and B? They are from the R, and R is my uncountable, so it has uncountably many values. A and B from the R, product will be the integer, so again it will be my here. Here you can see A and B is in the Q, and Q is my countable, so it is not be there. So the right answer is first, second and the third are the correct option. Okay, which of the following is my countable? So now you can think about whether it's a Q or Z, not in the R. Set of all those polynomials with the real coefficients. I can simply take A plus B of x. What is the A and B? Real coefficients. So what is the R? R is my uncountable. So you have the infinitely many values of the A and B. So this F is my uncountable, but we need a countable. Set of all the polynomials with the rational coefficient. That this is my here. Second portion is A and B is in my Q, and since Q is my countable, so A and B are countable, so polynomial is my countable. Set of all the polynomials with the real coefficients A plus Bx such that the root will be my minus A over B. This is in my Q, but what is the A and B? Real. So this is my uncountable, so it means fx is my uncountable polynomials. Set of all those 2 cross 2 matrix with the rational eigenvalues. So if I consider this is my lambda 1 and 2 are my rational eigenvalues, okay, what is my here A? So it is given that these are my eigenvalues, these are in my Q, but what is my A? They are not the eigenvalues, so they are the part of the real line. So since this R is my uncountable, so you have the uncountable matrices are here. So this is uncountable R here. So right answers are only B and C are the right answers. Okay, which of the following set is bijective? Bijective means 1 1 and on 2. So what is the meaning of that? We will check about that. Whose mapping coincides with the R. Fine. So what is the tips for you? Whenever you have the mapping from A to B, then the number of the maps, how many maps will be? Cardinality of the B raised to power cardinality of the A. So look at the first option. Set of all the map from this to this. What is the cardinality of the n? Divided by cardinality of the 0, cardinality of one n is this, cardinality of this is my 2. What is that? Is it countable or uncountable? So what is that? This is my countable, but what is the cardinality of the R? It's a C, counter number, which is a uncountable. So this mapping does not exist. Look at the second. Cardinality of the 0 1 is 2, cardinality of the n, what is that? It is here. What is that? This is nothing but my C, which is my uncountable of this, which is mapped with the R here. Set of all the subset of the n. What is the set of all the subset of the n? That is a power set. So you have to find the cardinality of the power set. This is nothing but 2 raised to power n, which is 2 raised to power, which is again C counter number, so it is my here. Set of all the subset of the R, that is the power set of the R. So you can see this is 2 raised to power of this, 2 raised to power of C, which is always be greater than of the C, which is not equal to C. So this is not a countable, or you can say it's a bijective map with the R. So right answers are B and C. Okay, let S belongs to the 0, 1, then which of the followings are true? So you can take any of the value in between them, say half. Fine. So I can consider S is my half. Greater than, what is the M? For all M. So if I consider M is my 1, for all M is 1, then there exists N. Can you find the value of the N so that this inequality hold? Yes, you can take N is my 3, you can choose N is my 4. So it means there exists N. So the first option is correct option. Look at the second option. Again, I can consider S is my half, M is my 1, so half less than 1 over. Can you think about this? Again, if you take N is my 1, then there exists here. So this is also. Now look at the third option. Again, you can think about S is half. There for all M, M is say my 1. Now you need a equality. So remember, the last two options are greater than. So if I consider M is my, N is here 1 by root 2, which is the part of this. So can you find the N which is in the natural number so that it will be whole? It is not possible. So it means this is not the right answer. Similarly, for the last option, if you think about this is my S, you can choose M is my say 3. Can you choose the value of the M, N, that is from the integer, from the natural number, so that it will be here? It is not possible. So the right answer is my A and B are the correct options. If you think about that, I can choose also here as this. Then again, still you can find the value of the N, like N is greater than of the root 2. So you can choose N is either 3, N is either 2. There exists. It is not set for all. There exists at least 1 is the right option. Okay, which of the following statement is my correct? F is a continuous mapping, continuously. So remember, if this map is my continuous, what is the meaning of that? If you define a connected set, it map on the connected set. If you define on the compact set, then it map on the compact set. If you define the open set, it map on the open set, and so on. Fine. So look at the first mapping, R to R, such that f of R is my Q. You can see R or Q both are in the same nature. It is not. Why? R is my connected, Q is my not connected. So F connected to be the connected. So this option is cancelled out. Second option is here again, Z is my not connected. So Z is not connected, but R is connected. So this option is cancelled out. Third option is F is the mapping of X comma Y such that is map on the circle. So here there exists. Yes, you can easily define corresponding to the each pair. We can define on the unit circle as cos theta and sin theta. So you can define a mapping from this to this. So there exists a one mapping which is here. There exists a continuous map from here. Close interval 0, 1. Sorry, that is a set consists of the 0, 1 only. So this is my disconnected set. Fine. If I prove that this is my disconnected, then also disconnected set to the disconnected. Clearly say that this is my disconnected because 0, 1 is here. 2, 3 there is a disconnected set. So disconnecting mapping to the disconnected over the continuous map is the right answer of this problem. So third and the fourth are my correct options. Okay, S is my infinite set. Which of the following statement is my correct? Okay, F is my mapping from S to N, which is my 1, 1 is given to you. So what is the meaning of that? Whenever it's a 1, 1, cardinality of this is less than of the cardinality of here. On the other hand, if mapping is from here is my onto, then remember this will be my here. Remember, converts not true. Converts not true. Fine. Now this is given to you. So what is the n? What is the cardinality of the n? This is my here. Fine. So once this will be here, this is my, what is that? It is my countable. N is my countable. What is the s? So once this is countable, the cardinality of the s is less than of the countable. So s is also be a countable. So the first option is correct option. Look at the second, s. If there is a onto mapping from s to n, this will be here. So this is my countable. Then since it is a greater than sign, so this is my uncountable. Countable or maybe uncountable. So it said it's a countable. That's not always true. F is the mapping from n to s. So what is the meaning of that? Cardinality of n is less than of this. So this is my alpha naught. So this is my countable, or you can say cardinality of the s is greater than of the cardinality of n. So if this is my countable, we can't say that s is my countable. And the last option is from n to s is my onto. So cardinality of n is my greater than of this, or you can say cardinality of s is less than of my here. So this is my countable. So it means this is also be a countable because it is less than sign. So the first and the fourth options are the correct answers. Okay, look at now, we are working on all those questions from the sequences and the series. An is my positive sequence, are my decreasing sequence. So there is any sequence, you can consider any of the sequence like of n minus 1, n minus 2 and of 1. Fine. Or you can consider any of the decreasing sequence, 1 plus 1 by n. Fine. When n is equal to 1, it will be my 2. After that it's a 1 point something, it's a decreasing sequence. Now look at this sequence, or you can see this sequence. If I consider this sequence, what is my an? Because we need a an will be my last term. It is my 1. So when it is a 1, you can see the first option is cancelled out. When it is 1, look at the third option is cancelled out because it will be my 1 over n, which is divergent by the p test, and is here. So these options are cancelled. Now again, if you think about here, again what is the limit? As n approaches of infinity, it is 1. So this option is cancelled out. If I divide it by this n, 1 by n plus 1 by n square, if I take the series, this is convergent, this is a divergent. So sum of the convergent and divergent is my divergent. Now rest of the two options are there. If I consider any of the sequence like of this, an is my 1. So what is that? This is my goes to the satisfied. If I consider this sequence here, 1 by n square is a convergent, is also the right answer. So you can consider any of the sequence which is decreasing and try to prove this result. Okay, look at this question number 63. AK is my unbounded. Can you think about any of the unbounded sequence? Very simple. K. This is my unbounded. Fine. So then I can find the value of the xk. So it is my k plus 1 minus k over k plus 1. So it is 1 over k plus 1. So xk will be here. Then for all n there exists, firstly we will check here. What is that? This is my summation of which is my divergent by p test, because the value of the p is my 1, which is less than equal to 1. It converges to the finite limit, cancel out. This is divergent, correct option. Fine. Now look at this first and this second option. So what is that? This is my k is equal to m to n. N is my greater than of the m. So that's a very simple. What you can think about that? I need a half. I can simply take n is my double of this. I can simply take that. So now if I open this, I can substitute this value as here. This is k plus 1. So if I substitute this, n plus 1, this is m plus 1, then m plus 2, and up to this is my 2 of m. So I can written as of this. So clearly says I can return this in terms of here m plus 1, this is m plus 1 plus 1, and here I can return this is m plus 1 of m. So it is m term. Now I need a greater than sign. How I can greater than? It can be greater than of, yes, anybody can, this is greater than of. How I can greater than? I can take denominator as less than. It is my here, so it is my 1 over 2m, and here last term is also be here. So how many terms are there? M plus 1 over 2m, which is greater than of the m over 2m, which is nothing but my half. So this option is correct option. Now look at this first option. Again you can think about xk, which is from k is equal to m to n, where n is my greater than equal to m. So that's again a very simple. How I can write that? If I write from the 0 to infinity, I can write this number as 1 to n plus remaining term, which is always be greater than of this part. Fine. Since it is a sum of them which is greater than or equal to x of, I can substitute the value of this. So at this particular point, say x of n. Fine. So that's over. You can see I can break them. If I write in term, this is 1 minus xn over xn plus 1. So I can take m and n must be greater than of this. So this is my n, this is my m, which is must be greater than. It's satisfied. So first, second and fourth are my correct options of this problem. Which of the following sequence is my convergent? So remember, whenever you want to try for the sequences, firstly you can check about of this. If it does not goes to the 0, then it is always be a divergent. Fine. Whenever there is a logarithm term, you always remember log of np is divergent when p is less than equal to 1, greater than 1, it's a convergent. So if you compare from here, p is my 1, which is divergent, but we need a convergent. This option is cancelled out. Look at this term. If I write the last term as 1 plus 1 over n of n, then consider as n approaches infinity. What is that? This is log of e, which is 1, which is not 0. So as per these steps, this is also be a divergent. Look at this first option. This option. This is 2 raised to power n over n square. If I take n approaches infinity, this will be my infinity by infinity. So then I take this derivative 2n log of 2n. Again it's a infinity by infinity. So it's a 2n log of 2 square over 2. It goes to the infinity. It means does not goes to the 0. So again this is my divergent. So this option is cancelled out. Only left option is there. So which is the correct option of this example. Otherwise you can simply prove that. How you can do? You can easily write in terms of this as Cauchy sequence, an plus 1. This is n plus 1 whole square minus 1 n square 2 raised to power minus n. So this is n plus 1 and this is 1 over 2, which goes to the half, less than 1. So it is a convergent by the ratio test. So this is the convergence. Okay, let R denotes the set of the real numbers, Q is the set of the rational numbers, such that epsilon is lies between here. A epsilon is the open interval of this. Which of the following is my here? That's a very simple, I think. Okay, so supremum of the epsilon, supremum of infimum. So what is the supremum of the A epsilon? 1 minus epsilon, because 1 minus epsilon lies between here, and infimum is my 0. Fine. So is there any option? No. So look at that. Firstly we will check about the second option. Epsilon 1 is less than epsilon 2. So for each epsilon, infimum of the epsilon 1 is 0, which is 0 of the infimum of epsilon 2. But he said less than. Cancel. Look at the third option. When epsilon 1 is less than epsilon 2, then 1 minus epsilon 1 is greater than 1 minus epsilon 2. Supremum of the A epsilon 1 is greater than of the supremum of A epsilon 2 is the correct option. Look at this supremum of A epsilon, which is 1 minus here. So I have to verify this of here. So what is that? Is it less than 1? So we can see epsilon is lies between here. I can take 1 minus. So I can take 1 minus will be here. Fine. So what will be the supremum of this? Supremum will be my less than or equal to 1. But he said strictly less than 1. This option is also cancelled out. Now look at the last option, whether here. So I can write this term. How I can open this term? This is supremum of A epsilon intersection R. It's a minus. So I can write this as a supremum of A intersection Q complement. Fine. So that's a simple. If I simply take any of the subset AB or open interval or any of the closed interval, then what is the A epsilon intersection AB? What is the A epsilon is the open interval. So intersection will be here. R is my real line. So if I take A epsilon is my A comma B, what is the A epsilon intersection R, which is itself a AB? What is the A intersection Q complement? This intersection Q complement. Now what is the supremum of this? Supremum always be lies in this upper limit. This is a B because they are independent of this interval. So this is my B, this is my B, both are same is the right answer of this problem. Okay, which of the following is my true? That is a integration is there. Okay, that's a very simple. Firstly, we will check whether it's a continuous over the domain. So domain is my 1 to infinity. Okay, fine. Cos of t is well defined. 1 over x square plus is continuous for all x and t. This is continuous for all x and t. So the ratio of them is also be a continuous for all the domain. Fine. Now it is not defined everywhere. That's a wrong option. How you can check for the bounded? That's a very simple. Every continuous function is a bounded function also. So that's also the correct option. Otherwise we can start from here. This will be less than or equal to 0 to here. I can write because cos of t is my less than 1. So it is my tan inverse of here. So infinity will be my pi by 2x, which is my finite number. Fine. So fx is less than of something is a bounded, but we already proved that it's a continuous, implies it is a bounded. So A and B are the correct options. Okay, fine. This one is there. K is my limit supremum mod of an. Which things come in your mind when you think about here? Radius of convergent. Radius of convergent is my 1 by k. Fine. Now what you can think about that? That's a very simple. What is the shortcut tips if you remember that? Can anybody remember how you can solve this question? So remember, if r is 0, if we find that radius of convergence 0, what is the implies that? It is not convergent. Power series is not convergent. If you prove that r is infinity, this implies it is convergent everywhere. So look at this shortcut tips. K is equal to infinity. It means r is 0. R is 0 means not convergent, but he said a convergent. Cancel out. K is infinity. R is 0. Not convergent. Not convergent. Correct option. K is 0. K 0. R infinity. Convergent everywhere. Convergent for every r. K is 0. R is infinity. Convergent everywhere, but not convergent. Cancel. So simple. You can remember these tips for you as here. Okay, consider the sequence xn. This is a positive sequence. Yn is my here. Then which of the followings are my true? Okay, that's simple. Now they are talking about only for the sequence, not for the series. How you can prove that? xn is convergent if yn is convergent, xn is convergent, yn, okay. So firstly I can take xn is my convergent. So sequence is convergent when you take as a limit it is a finite. It is a finite, then we call as the sequence is convergent. So if I simply take 1 by n, it is finite limit, so it is my convergent. What is my yn corresponding to this? 1 over, again this limit is my finite, so it's a convergent. If xn convergent, yn convergent. Fine. Yn convergent, xn is convergent. If yn is convergent, if I take yn is my n over n plus 1, fine. So what is the limit is? 1, it means it's a convergent. So corresponding to this, what is my xn? This is n. Is it convergent? No. This is my sequence is divergent because limit is here. So if yn is convergent, xn is convergent is the wrong option. Look at this next one. Convergent bounded and so okay, you can think about any of the bounded sequence. 1 by n is my bounded sequence. Then what is the y of n? If I substitute here, it is my n over n plus 1. Is it a bounded? Yes, it is a bounded. You can write like of this manner. Again, it lies between 0 and 1. xn is bounded, yn is bounded. Correct option. Okay, can you think about of this? If I say this is my yn, which is a bounded as I discussed here, what is the corresponding xn from here? If I think about from here, then xn will be my n, so which is my unbounded. So xn is yn is bounded in here. This option is cancelled. So the right answers are second and the third. Okay, look at this simple remark for you. Okay, so firstly, remember this simple remark in terms of this. This is convergent. This is divergent. This is convergent when n is less than 1. It is greater than of the 1. But anyhow, another tips for you is, if you have the fx is less than of the gx, if you prove that this is my convergent, this implies this is my convergent. On the other hand, if you prove that this is my divergent, it implies this is my divergent. And we all know, we always working on the ratio. If you find the limit as a finite and non-zero, then f and g both same nature. Fine. So look at the first option. P is equal to minus half. If I substitute here, so it will be my sine of t over t raised to power half, which is less than of 1 over this. So this sequence, as per here, it is my convergent. So once this is convergent, this implies this is also convergent, is a convergent. Correct option. Look at the second option. This is sine of t divided by t raised to power 3 by 2, which is always less than of here. Now this is my divergent, but we can never say this is a divergent. Converse is here. If you prove this is a divergent, then this is true. So it means this result is not applicable. Then we can apply here. So if I consider this is my here, what is the g? We all know sine t upon t is my 1. So the remaining is my here. So f over g as t approaches infinity is my finite, but this part according to this is my convergent. So f is also be a convergent. So this is my convergent, but he said divergent. Wrong answer. Look at this third option. So what is that? This is t raised to power 4 over 3 sine of t. So which is a proper integral? There is no breaking point for that. So it is, this limit will always be give you a finite. So that's a convergent. That's a simple convergent. When p is equal to minus 1 by 4, so it is my sine of t over t raised to power 4 by 3, which is again less than of 4 by 3. But this, according to this, is my divergent. But we can never say this is also be a divergent. Then we consider f is my sine t upon t raised to power 4 by 3. G I can consider as 1 over t raised to power 1 over 3. So if you take as a ratio, it will be 1, which is finite, and this, according to this, is my convergent. So this is my convergent, F is my convergent, but he said divergent. So the right answers are A and C are my right answers. Okay, look at this next option. What is given to you? Fn is a sequence of the real number. Suppose it converges to a continuous function uniformly on each closed and bounded. This is given to you. What is the meaning of that? Fn converges to F uniformly on the compact set. Fine. Then remember the tips for you. What is the tips for you? If it converges on the compact set, then Fn converges to, first of all, R is not a compact set. Is it a compact? No. So what is the meaning of that? Fn converges to F uniformly on the R is the wrong answer. But if Fn converges to F on the compact set, it means Fn converges to F pointwise also on the compact set. But since pointwise is the weaker one, so it holds even for the R as well. For the sufficiently large value of F, Fn is a bounded. So can you think any of the sequence which converges to the bounded? Any of the sequence like of this, which can be written like of this, x raised to power n over n factorial. Now whenever n is my large, so clearly says that this is my unbounded. Fine. So F is my bounded for the sufficiently large is a wrong answer. Now what is the result for you? Since F is not a bounded for the sufficiently large, what is the meaning of that? F is not a continuous for a large n. So F is a continuous for a large n is also the cancel option. Remember always, you all know continuous implies bounded. What is the opposite of this? Not bounded implies not continuous. So according to this, so this option is, that's only the second option is the correct option. Okay, look at this option. An is a sequence xn 1 minus x. Fine. So which of the following converges pointwise or not? Take n approaches infinity of this ax. What is happen? If x is 0, limit will be 0. If x will be 1, limit again 0. If x belongs to the 0, 1, so any number which is like of 1 over y, so 1 over y raised to power infinity will goes to the 0. So it means a converges to the 0 pointwise. So similarly for the Bn, so Bn is an alternating series. If you take the absolute value, so it will be converges absolutely. So a converges pointwise. Firstly, how you can check for the Bn? So Bn is also be here. So because it's x approaches 0 is here, so both are converges pointwise. Now which of the following is converges absolutely? Uniformly. So how you can prove for the uniformly? We always apply the Mn test. Supremum of x belongs to the 0, 1 of ax, pointwise convergence is 0. So what is that? Supremum x raised to power n 1 minus x of 0, 1. So now you can check about the limits. So if I simply take of this, find the derivative and put them as a 0. So n xn minus 1 and minus x of n. So if I take x raised to power n common, so it is n over x, 1 minus x minus 1, it is a 0. So x raised to power n will be 0. So n over x minus n minus 1 is 0. So x will be my n over n plus 1. I can substitute here. So what is the value of this is 1 over 1 plus 1 over n raised to power n, 1 minus 1, it will be 1 over n plus 1. So as n approaches infinity, this is my e, so 1 over e, this will be the 0, so it goes to the 0. So an goes to the 0. So is it convergence? Yes. Whenever Mn test goes to the 0, it will goes to the it goes to the uniformly convergence. So an converges uniformly. Now what is the Bn? So if you take the modulus value, it is less than of, so this is a convergent, so Bn is also convergent uniform. Okay, now this is the most important thing for you. Fn converges to L for all x. It is not uniformly. It means this is my pointwise. Now f is my integrable. Fine. So what is the tips for you? So remember always, if f is integrable, f is uniformly convergent on the closed interval a comma b, then only you can define as a limit of the fn is integration of the fn as a equality. Remember, on the closed interval. So you can see this is not a closed interval. Although f is integrable, but it is not given that f is uniformly continuous. It is nowhere given that. If it is given to you, then it is fine. Here it is a 0 to infinity. Not true. Fn converges uniformly on this here, then now it's a uniform convergent given. Here is the limit is closed interval 0 to 1. Then this will satisfy. This is not the closed, cancel out. This is my closed, so it converges uniformly. So right answers are B and D. Simply remember these simple tips. Okay, Fn is a sequence of the continuous function. Define which of the following statement is correct. Fn converges to f pointwise on the closed interval 0 comma here. Now you can see the same remark for you here. Limit of the Fn, integration of the f. This equality will be happen only when it is a closed interval 0 comma 1. So it is not a closed, cancel. It is not a closed, cancel. They are not equal, so it's a correct option. Look at the third option. Okay, if Fn converges to f uniformly, what is the meaning of that? Fn is converges to uniformly, so every uniform continuous function is a continuous, so f is my continuous. Right answer is third, also the right answer. Okay, look at this another one. Function is given to you as fx minus fy is less than of cos x minus cos y, and we all know cos x minus cos y is less than of this. So you can see here, do you remember which condition will hold here? Yes, f satisfies my ellipsis condition. So once it will be here, it means f is my uniform continuous. Once f is my uniform continuous, f is my continuous. So f is discontinuous, that's also discard option. It is already given that f is a continuous function. F is continuous everywhere on the 0 1, but not uniform convergent. Cancel out. F is a uniform convergent continuous, correct option. Once it's a continuous, what is the meaning of the continuous? Continuous on the interval, limit always exists. Then only it will be the continuous. So the right options are C and D are my correct options. Okay, look at this option. So Fn is there, pointwise convergent. So we will firstly look about the pointwise sequence as n approaches infinity. What is that? Closed interval 0 comma 1. When x is equal to 0, answer is 0. When x is equal to 1, it will be minus 1 raised to power n. So it will be either plus 1 or minus 1, depending upon the nature whether it's even or odd. And whenever x lies between 0 and 1, it will be anything power lies between 0 and 1 raised to power n is my 0. So clearly say that limit not unique. So it means Fn converges to f pointwise, not holds. So f converges pointwise everywhere, cancel out. F has no pointwise convergent subsequence. So when it will be the pointwise? When you get the limit as same. So if I discard this option 1, if I define a sequence 0 and 0 when x is 0, 0 when x lies here, like if I define the subsequence same function when x is in 0 is include but 1 is not include, then clearly say that the limit of fx will be 0. So it means it has a subsequence which is my pointwise convergent. So there is no pointwise convergent subsequence cancel out. Now the fourth option and the first option said there exists up one point has exactly 1 point. That's again wrong option. How many points are there? There are infinitely many points. Like if I say f of n 0, it will be 0. F of n of half, this again a subsequence. F of n 2 by 3, again a subsequence. So all are my pointwise convergent. So there is exactly one cancel out. There exists a pointwise convergent subsequence. That's the correct option. Okay, which of the following sequence is my uniform convergent? So this tips I already given to you. F is a uniform convergent on this closed interval a comma b when you prove that limit a positive f and limit x approaches b minus fx both exist. If both exist, then you can say it is a uniform continuous. So look at that. Limit x approaches 0 minus ex exists. Limit x approaches 0 positive and 1 minus of fx both exist. Correct option. X, correct option. Limit x approaches 1 minus of tan pi by 2 x which goes to the infinity does not exist. Limit 0 positive 0 exists, 1 positive exists. They are simply saying exist. Whether they are equal or not, that is not a big problem. So the right answers are A, B and D are the right answer. Okay, look at the next question. So this again a pointwise convergent or not. So we can take the limit of this on the open interval 0, 1. So when you take the limit as n approaches infinity, it's a 0. So it means fn converges to the f pointwise as a 0. Similarly, if you take it as a gn, when you take that as the limit as n approaches infinity, it goes to the 0. So both converges pointwise, but he said uniformly. So we can define here fn minus f. So supremum of the x belongs to the open interval 0, 1. This is my 1 over 2 nx plus 1 here. Now you want to find the maximum. When it will be maximum? When this part will be minimum. So this part will be minimum corresponding to the x is equal to 0. So what is the value? It is 1, which is not goes to the 0. So remember, whenever mn goes to the 0, then it is a uniform convergent. So it means f is not uniform convergent. Look at here. If I define the supremum x belongs to the 0, 1, this is x over 2 nx plus 1. Now since the numerator is not a constant, so the first tips for you is you can put denominator as a 0 and find the value of the x irrespective of their sign. Plus minus you can forget that. So then you can substitute this value here, 1 over 2n over 2 as n approaches infinity. So this will goes to the 0. So this condition satisfied, it means G is my uniform convergent. Second method is, as I discussed earlier, you can take x is my 2nx plus 1. You can substitute y dash is 0 and find the value of the x. You can try to do it. Again you will get x as 2 by n. So if I substitute x is my 2 by n here, you will get as limit 0. So this is not a uniform convergent. G is my uniform convergent. So second is my true, first is my false, is the right answer of this problem. Okay, which of the following is now series convergent? First one, convergent. So you can see by the Leibniz test, it is a convergent. Leibniz test means an is decreasing and an goes to the 0. So you can see in the first term, this is my here. This is a decreasing, derivative will be negative, goes to the 0. So it is a convergent, correct option. Is it absolute convergent? If I take the absolute value, so what is the absolute value of this? It will be 1 over root n plus n. So you can see this is, what is the highest power of the n from denominator? N, which is my divergent by the p test. So it means this is not absolute convergent. Look at this third option. I open this summation firstly. I can return this as a root n plus minus 1 root n plus log of n divided by n raised to power 3 by 2, n raised to power 3 by 2, n raised to power 3 by 2. So what is that? This is 1 by n, this is here, and this is my log n over n raised to power 3 by 2. Now clearly sees this term is my divergent by the p test. This is convergent by the which term? Leibniz test. But one series is divergent, it means complete series is my divergent. So it is a convergent cancel out. Look at this one again. I can open this summation. So it is minus 1 raised to power n factorial is here, plus n raised to power 3 by 2. Now clearly say that this is convergent by the p test, this is convergent by the Leibniz test. Sum of the two convergent series is convergent. So the right answer is A and D are the correct answers. Okay, look at this series. Which of the following is not convergent? So we need a divergent. Look at the first option, mod of A less than 0. I can simply take A as my 0. So what is my series? 0. Fine. So this tips I already mentioned you each time. Constant series, remember, constant series is divergent always except 0. Like this is a constant series, but it's a 0 is a convergent, while constant series of the 2, constant series of 3 all are my divergent. So here it's a constant series of the 0 which is my convergent. So the first option is convergent, but we need a not convergent. Look at that. I need a b is greater than 1. So I can take b is my 2. C can be any real number, so I can take C as my 0. So what is that? A is my 1. So it is 1 over n square. Anything power 0 is 1. So this is my convergent by the p test. So this option is also cancelled. B lies between here. So I can simply take b is my 0. C can be any number which is less than 1. I can take C also as a 0. So what is my series? A is my 1. Anything 1 is 1. So that is my series is 1. So which is a constant series? Every constant series except 0 is my divergent. So this is the right answer. Look at this here. I can take B as my 0. C is my greater than. So I can take C as my 1. So what is that? This is minus 1 raised to power n log of n, which is my convergent series by the Leibniz test. But we need only the non-convergent. So this option is cancelled. Only the C is the right answer. Okay. What is given to you? Supremum of this is less than. What is the meaning of that? Do you remember that? If that is a F is my uniform convergent. Once F is uniform convergent, it means F is my continuous as well. So F is a uniform convergent, correct? Now they are Cauchy. So if F is a uniform convergent, it means F is my Cauchy sequence as well. So F is a Cauchy sequence, map Cauchy to Cauchy. F is a continuous, F is also be a convergent. So F maps to the here. F is also be a bounded. So it's a bounded sequence to the bounded sequence is the right answer. Okay, which of the following sequence converges uniformly? So you have to start with the modulus sign. So what is that? This is a negative power. So it will be less than of n cube, which is my convergent by p test. So once is a convergent, so it means this is the uniformly convergent. You can start with here modulus sign, which is less than of n raised to power 5, which is again convergent by the p test. Here you can't take as a less than, but you can see x is less than of this. So I can return this number. If I start with the modulus, this is the same number. So this is less than of pi raised to power n, n raised to power n. So what is that? If I consider this is my here. So what is that limit of this? Limit an of 1 by n by the root test. 1 over 1 is my 1. So you can't say that whether it's a convergent or divergent because it's a equality appears. So how you can say this is a convergent or not? So you can apply, you can see here, this is my an complete, fine. So if I take this number, this is my pi. So 1 over pi is my less than of 1. So it is my convergent. Fine. Look at the last option. Here x belongs to this. So if I simply take limit x approaches minus pi of this, so it is approximately be a 0. So once, because sorry, it's not be a 0, it is limit does not exist, limit does not exist, because it's a minus 1 plus pi, it's almost infinity. And I already tell you, whenever you are talking about this, if this limit will not goes to the 0, it is always be a divergent. So this is a divergent. So limit does not exist means it's a divergent series. Okay, bounded variation. Remember these tips for you: x raised to power alpha, sine x raised to power beta. This, or you can say cos, these are the same thing. Here, whenever alpha is less than 1, then it is my bounded variation, otherwise not. So this is bounded if alpha is my greater than beta. So if you compare them, alpha is my 2, beta is my 1, either the sine or cosine, that's a simple rule. So 2 is greater than 1, so f is my bounded variation. F dash is a bounded variation. You can take the derivative. Firstly, you can check that 2x cos 1 by x, and it will be minus x square, it will be cancelled out, it will be here. Now it is my 1, it is 1, but it is a strictly greater than, it is not a bounded variation. Also I can written this as x raised to power 0, 0 is less than of 1, it is not a bounded variation. Now you can check about the modulus of this. What is the derivative of this here, which is less than of 2 mod x, cos is always less than 1, x0 is 1, it is here. So what is the x on the closed interval of this? So it means x is less than or equal to minus 1. It is less than of 2 into 1, 2 into 1, 2 plus 1, 3, less than equal to 3 is the right answer. Third is the cancel. Okay, fn is a sequence of the continuous real value function such that f of n is my decreasing and f of n converges 0 uniformly. Then consider the gn, which is my minus 1 raised to power n fkx. So what is that? It satisfied my Leibniz test for the sequence. So what is the meaning of that? Gn is my uniform convergent. Once G is my uniform convergent, need not converges pointwise, cancel out. Every uniform convergent implies is a pointwise convergent, but converse need not true. So this is cancel out. If it is a uniform convergent, it means it is a Cauchy sequence as well. So this is the right answer. If it is a uniform convergent, it is also be a bounded as well. So you can see there exists them, it is a bounded as well. So also, as I discussed here, it is a convergent also, it's a continuous also, Cauchy also, bounded also, each of for the uniform convergent. Okay, look at this one. Again, this is a similar of this, which of the following is the bounded variation. So f of x is x sine 1 by x. So you can see the power is 1, alpha is 1, beta is 1. So alpha is not greater than of beta. So f is not bounded variation. What is a g? G is nothing but my x into fx. So what is that? This is x square sine 1 by x. So alpha is my 2, beta is my 1, which is greater than of the beta. So it is a bounded variation. G is not cancelled. Okay, look at that. This is the question related to the Riemann sum and upper. So this option is obvious. Upper Riemann sum always greater than of the lower. Upper can never be less than of the lower. Now it is a greater than. So we all know Riemann upper sum is always be greater than of the Riemann lower sum. But equality also, when it will be the equality? Equality occurs only when this g will be my constant. Okay, so if you construct this g, if it is a constant, then you have to say it is a equality. So how you can define a function to be a constant? So my function will be here. G is any strictly increasing function. So you can simply take any of the increasing functions, say x. Can you say g is my constant from here? What is my g? It is x 1 by x. When it will be the constant? If I subtract 1 by x, what is the opposite of this? if I subtract x from here, then it will be 0. So it means if I consider this is my fx, what will be my f 1 by x? You can see here. So if I consider this f, then g will be my 0, which is my constant. So once it will be constant, then you can see here this equality will be hold, because he said for a suitable f, and you can see this function is an increasing function. You can check it firstly. X, you can check about the derivative. This is 1 plus 1 by x square, and clearly say that it is my greater than 0 for this domain. So it means this is an increasing function, so it means this existence for that. It is not equal to. So again, how you can check for the not equal to? So we can take for not equal to for the partition. So I can take the partitions of 1, 2, because P is the partition of the 1, 2. I can simply take partition as say midpoint of this. Fine. And f of x I can simply take as a x. So g will be my x plus 1 by x. Fine. Then we can define the upper limit, UPF, UPG. So what is the difference is my half g of 3 by 2. What is the difference is half g of 2. Similarly, you can define the lower difference is half lower limit g1 half middle number is 3 by 2. Now if I subtract them, you can see here this number will be cancelled out. U minus L, half is common, g of 2 minus g of 1. So what is the g of 2? F of 2, g of 2 is my 2 plus half minus 1 minus half. So clearly says 1 minus 1, sorry. So it will be my 1 and 1 cancel out, 2 it will be my 1 by 4, which is non-zero. So u minus L is a non-zero, means u minus L is here is also the right answer. So first, second and third are the correct options. Okay, which of the following is properties defined as f is continuous and f circle f is my f? So firstly, you can check about the continuity and the f circle f. Okay, clearly say this is a non-linear. So this property does not hold. Why? If I consider any of the point from here, say f of 3. So what is that? This is f of 3. What is f of 3? 9. 9 again lies in here. So 9 is 81, which is not equal to f of 3 as per here. So this option is cancelled. This is a linear. So this is a continuous. This is a continuous. This is continuous. And it's a linear. So you can see if I take f of this x1 0. So again it will be that, because it's a linear, so it is a satisfied all property. It's a linear, it satisfied all properties. But we will check about the continuity. So what is that? Whenever x minus 1, it is my minus 1, it is minus 1, continuous. 1, 1, continuous. It is a continuous because of the linear, this satisfied. 0 is a 0, 0 minus 0. 1 minus or 1 plus 1, 1 is a continuous. Minus 23, minus 1, minus 23, 23 minus 23 minus 1. 27 minus 1, it's a plus 1, it is my plus 1. So you can see this continuity will satisfy me. You can see here, this is my minus 23, 2 plus 27. The function value will be 1. Less than of this will be my 22 plus of x, and of here will be minus 26 plus x, which is not a continuous. At x is equal to minus of 23, limit value will be plus 1. Here is minus 1. The function is not continuous. So once f is not continuous, so these options are cancelled. Okay, now look at this another option. F A is the subset of the R. A is the any subset of the R with more than one elements. A is here, then A minus A is my compact. What is given to you? A, this is my compact. Fine. Now we all know this is my singleton. Every singleton set is a closed as well as bounded, so it is my compact. So this is a compact, this is compact. If I take union of this, what will happen? This is my A. So this is compact, it means A is my compact. Fine. So first option is the correct option. Every subset of A must be compact. So if I consider A is my singleton, say 3, and if I consider any of the set A as a subset of the R, this is subset of the R, then what is this? This is my compact. Fine. Now if I consider any of the subset, if I say B, open interval 1, 2. Fine. So clearly says that this is my bounded. Fine. Is it compact? No. So it means every subset of the A, this is a subset of A, this is a subset of A, must be compact. It is not true. A must be the finite set. That is not true. A is the subset of the R. What is the cardinality of the A? Is less than of the cardinality of the R. That is Cantor number. So this is a uncountable. So this is not a finite set. Must be a, that is not true. A is my disconnected. Okay, how you can prove that it's a disconnected? Again, a very simple. You just think about the definition of the disconnected. How you can say that? How many elements in the A? A has more than one element. That is given to you. It means A is not my 5. A is not my singleton. Not singleton. Fine. Because it has more than one element. So what is the nature of the A? A can be of this closed interval. A can be of this open interval, semi-open. A can be of this, or A can be of this. Fine. Because A is the subset of this R. So clearly says that all of this are my consist of more than one elements. Fine. And clearly says that these are my disconnected sets. As we all know, in the real line, the subintervals are my disconnected. So this is my right option. So A and D are my correct answers. Which of the following is not compact? Which of the following is not compact? It means we will prove that either the not closed, or we can prove that not bounded. So very simple. Look at the first option. It's a circle. That is here, which is a compact, because it's bounded as well as closed both. So not closed cancel out. Look at the second option, which is my greater than 1. So that is my outside portion. So what is that? It is not bounded. So once it is not bounded, it means this is not compact. So third is the correct option. Look at this one. It is open. That is, a boundary points are not included. So once boundary points are not included, it means it is not closed. So this means this is not closed, means this is not a compact set. What is that? This is my circle. So how you can define the circle? Circle will be my only on the boundary points. Only on this boundary point. So once you can say it's a boundary point, what is the meaning of that? It is closed. Fine. Once it is closed, because every limit point of this, whenever simple, you can always remember, whenever there is a curve, every curve is my close. So this is my curve, it is a close. Every limit point is in lies on here. It is also the bounded. So it is my compact, but we need a not compact. Right answers are second and third. Okay, f is a monotonically increasing function. Then which of the following is my satisfied? Okay, f is monotonically increasing function. So f dash is my greater than or equal to 0. This is given to you. Then which of the following is here? F is a continuous monotonically increasing from the 0, 1 to 0, 1. I think that's again a very simple. As I mentioned you in my previous lecture on this reanalysis, what I tell you, whenever you have a discontinuous functions, or you have any of the monotonic function, what kind of the discontinuities they have? If you remember that, as I mentioned you in my previous lecture, if you have a discontinuous function, then what kind of the discontinuous function they have? They have always be a discontinuities. Every monotonic function has a discontinuity of this first kind. Like any of the monotonic function, you can say a greatest integer. Fine, this is my greatest integer. They always have the discontinuity of the first kind. And how many discontinuity points are there? They are always be a countably many discontinuous points. So now you can check about that. Which of the following statement is there? F must be the continuous, correct statement, but finitely many points, not option. F is a continuous, correct option, but countably many is a correct option. Now how you can check about the Riemann and the Lebesgue? We all knows if it is a Riemann integrable, then it is a Lebesgue as well. Fine. So it means if third option is correct, fourth automatically be a correct option. Now what is the another remark for you? Every monotonic function, whether it's increasing or decreasing, it implies a Riemann integration. Every monotonic function is a Riemann integrable function, so this option is correct. Every Riemann integrable function is a Lebesgue integrable, so this is also the correct option. So B, C and D are my correct options for this example. Okay, look at this another question. This is related to the metric space. Firstly, I will tell you the tips for the metric space. If D1 and D2 are my metric space, fine, then sum of the two also be a metric space. Alpha times of this is also be a metric space, provided alpha is a greater than 0 and the real number, and this over 1 plus this is also be a metric space. Now look at that. This is the usual. These are the following matrices are there, so these are the metric space. So sum of them is also the metric space is the correct option. E of pi, which is greater than 0, that's a real number. E raised to power minus pi, again alpha, which is greater than 0, a real number. So e raised to power pi is also the metric space. E raised to power minus pi of D1 is also the metric space. So sum of them is also with the metric space. Negative is not be there. Why? Because we all know metric space has the property it should be greater than 0. So if I say D1 is greater than 0, D2 is my greater than 0, what will be the difference? It may be less than 0 or it may be greater than 0, but this is not always greater than 0, so the second option is cancelled. Now first option you can think about here, because we all know D1 plus D2 is a metric space. So if I consider this as say my y, so what is that? Y over 1 plus y is also be a metric space. So first option is also the correct option. Okay, look at this another one. Now you can see nothing is given to you in terms of the numerical information. So it means you have to use about the standard result. So what is the standard result? That's a very simple. Whenever you have a distance is 0, if and only if x belongs to the closure of this S. That's a simple tips for you. Fine. Now look at the first case. If S is closed, what is the meaning of the S is closed? It is given to you. It means S is nothing but my S closure. Then and distance of this is my greater than 0. As I told you, S is my any non-empty set. This is 0 if and only if X belongs to the DS closure. It is greater than 0. What is the meaning of that? X does not belong to the S closure, because S closure is nothing but S. What is the meaning of that? X does not belong to the S. What is the meaning of that? X is my not the limit point of the S. Limit point is also called as the accumulation point. So X is not the limit point. X is not the limit point. That's the correct state. Second is S is my open. So in this case it is not be there. So again this is my greater than 0. It means X does not belong to the S complement. Once it will not belong to the S complement, what is the S complement is there? S complement, that's the closure of this. It means X does not belong to this, because it's an open set. You can say X does not belong to the derived set, but the limit points are there. So what is the meaning of that? X is not a limit point of this S, so it is also be here. So what is that? S is, third option is S is closed, limit, this is greater than 0, again S is closed, it is greater than 0, X is not be there, S does not contain X, so that is again here, fine. If S is open, then this is 0, this is 0 if and only if S belongs to the here. So look at that, S is open, it means S is not equal to the S complement, fine. So once S is not equal to the S complement, it means this will not be a 0. So S is open, and here what is the meaning of this line? This means X belongs to the S here. So once this will be belongs to the here, and then X belongs to this, so that's a wrong statement. It happens only when S is my closed set, so it means this option is my false option. Remember, this is the correct statement when S is my closed. F is closed, then both are same, then it will be hold for that. Okay, look at that. E is the subset of the R. Characteristics function of the E, how you define that? It's a 1, it's a 0, X belongs to the E, X does not belong to the E, fine. E is closed, E is open, and so on. So let's say E is my closed, this is my closed, so it means here whenever this will be here, it is 1, otherwise 0, fine. Then this will be continuous if and only if. So what is the definition of the continuous? Limit at the endpoints exist and equal. That's the meaning of the continuous function. Now look at that. What is the limit at X approaches A minus of the F? 0, that's existence. Limit X approaches A positive of this F, or F means xi. If I call as F is xi, it is 1. They are both exist, but they are not equal. It means this, when you take as a closed interval, E is my closed interval, then it is not continuous, but he said continuous. So first option is cancelled. Look at that. If you taken as the open interval A comma B, this value is 1, otherwise 0. So again, when you take the limit as X approaches A negative, the value is 0. When you take limit as X approaches A plus, it's a 1, again not a continuous. Both open and close is a cancel out. It's neither open nor a close is the right answer. Okay, which of the following are my correct statements? So how you can think about that? Okay, F is my sin x minus x plus x cube by 3 factorial. G is my cos x minus 1 x squared by 2 factorial. Okay, if I take the derivative of this F and derivative of this G, because we need a F and G both are increasing, decreasing. So it is my cos x minus 1, this will be 3 will be cancelled out, plus x square over 2. What is that? This is nothing but my G. This is my G. Fine. Now, what is my G dash? It is my minus of sin x. It will be 0 plus of x. That is x minus sin x. Now, we all know sin x is always be less than or equal to x. So, it means this number will always be greater than equal to 0. What is the meaning of that? G dash is always be greater than 0. It means G is my increasing function. So the first option is, second option is correct. Third option is cancel out. Now, G is my increasing function. We get F dash is my G. Fine. So F double dash will be my G dash is my greater than equal to 0. So F double dash will be my greater than 0. It means F is my convex function. Fine. So once f will be convex function, it means this is my greater than equal to 0. This is also the correct option. So f can never be decreasing function because f is my here. So right options are first and second are the correct options. Okay, look at this next one. F of t is given to you from this. Which of the following are necessary correct? There exists some derivative here. So firstly we can find the derivative. Minus sine t cos of t. Fine. There exists some t such that f dash of this is there. So firstly we can find the value of the f of 2 pi. What is the f of 2 pi is 1, 0. What is the f of pi? Minus 1, 0. Then you can subtract them. If you subtract them, you will get as a 2, 0. If you divide it by pi, so it will be my 2 over pi and 0 over pi. Fine. So it will be equal to sum of t, sine of and cos of t, which is not possible because there is no value of the t for which cos is 0 and sine is 2 by pi, because if cos is 0, sine will be 1. So it means the first, there exists some t0, cancel. There does not exist any of t such that this condition holds. That's true. There exists some t0 lies between pi to 2 pi such that this property holds. So if we start from the left hand side, f of 2 pi is my here. Minus of this, it will be my norm of 2, 0. So what is the norm of 2, 0? So 4 plus 0 is my 2. Left hand side is my 2. What is the right hand side is pi. Norm of f dash. So that will be my minus sine, cos of this. So what will be the norm is sine square plus cos square, that is my 1. So according to this, it's a less than equal to pi. Is it satisfied? Yes, it is satisfied. F dash, that's a simple derivative rule. So as we derive them, it is a correct answer. So second, third, fourth are my correct options. Okay, look at this another one. F is continuous, G is continuous. Okay, G is continuous everywhere, G is continuous everywhere. Okay, firstly we will think about this here. X plus y over x square plus y square. So I can simply take y is equal to mx. Fine. So what is that? This is 1 minus cos 1 plus m times of the x divided by x square common 1 plus m square. Now take the limit as x approaches 0. 1 is a 0 by 0 form. So then we apply the L'Hopital rule. Sine 1 plus mx into 1 plus m divided by 2x 1 plus m square. Fine. So I can multiply this by 1 plus m, multiply by here. So as x approaches here, I can multiply by 2 also and divide it by 2. So this value will be, no, I can take this separate 2. Fine. Now this value will be 1. So the rest of part will be 1 plus m whole square divided by 2 1 plus m square, which depends on m. So it means f is not continuous at 0, 0. F is continuous 0, 0 cancel out. F is continuous everywhere except at 0, 0. So what is the value of this except 0, 0? Half. So that means when x is except 0, 0, so that's fine because whenever is there, so you have the function of this, the left hand limit and right hand limits are always same because it is not equal to the here, so it means it is a continuous everywhere. G is continuous 0, G is continuous everywhere. So how you can check about the G again? So we can check about this G again. I can take the part y is equal to mx. So 1 minus cos 1 plus m times of the x divided by 1 plus m whole square of x square. So again it's a 0 by 0 form. So if I divide them, 1 plus m of x into 1 plus m divided by 1 plus m whole square of 2x. So I can break this m and this m cancel out. The rest of part will be my half, and you can see this value is my half. So it means function is continuous at my 0, 0, and apart from the 0, 0, the function is continuous everywhere. So this is also the right answer. So right answers are second, third and fourth are the correct option. Okay, look at this next one. Which of the following function is my differentiable, differentiable, differentiable? That's a very simple tips for you. Remember, whatever the function is given to you in examination, they can give you like of this also, they can give you like of this also, anything are there. So what you can think before solving is there. So you can see this is my given to you. Now they are talking about the differentiability. So we all know mod of x is not differentiable at x is equal to 0. Fine, only. That's the rule. Now look at that. This is x square, which is differentiable everywhere. This is not differentiable. So mod x is not differentiable at x is equal to 0. This is also the mod. So when it will not be differentiable, x square minus 1 is not differentiable when x square minus 1 is 0, that is x is plus minus 1. So it means this function f is not differentiable at x is 0, at x is 1 and x is minus 1. Fine. Now look at the option. F is not differentiable exactly at the 3 points. That's fine, because this is the polynomial, it is differentiable everywhere. F is not differentiable at x is 0. Fine. F is differentiable at x is equal to 2. Fine. F is not differentiable at 1 and minus 1. Fine. If he said it is not differentiable only at this, then the option is cancelled out. But here they are talking about at this point as well. So this is the right answer. Okay, look at this last question, I think. Yes, this is the last question. And that's a very interesting question is there. So as I give you very simple tips in the earlier videos, whenever there is a sequence or whenever there is a series of the convergent and absolute convergent, you always think about this example. Fine. Now, what is that? If I consider this series, clearly say that this is convergent by the Leibniz test, this series is not absolute convergent. Fine. And the sum of this an is by 0. You can easily see what is the 1. And sum of the an, what is the an is minus 1. It's a plus 1. When n is equal to 1 here, then it's a minus. It's a plus 1 by 2. Oh, sorry. It's a when n is 1. When n is 1, it will be my minus 1. When n is 2, it is my plus 1 by 2. N is 3, it's a minus 1 by 3 and so on. Fine. It is given that it is not absolute convergent, and here then let Sk denotes the partial sum. But this condition is not satisfied. The sum is not 0. We need a sequence which satisfied this condition as well as this condition, which is not satisfied for this case. So it means this example is not applicable in this case. So we have to think about the another example. So what you can think about that? That's very simple. I can simply consider this example like 1 minus 1, half minus half, 1 by 3 minus 1 by 3 and so on. So clearly say that this condition satisfied. This is a convergent sequence, because easily see that absolute value, it is not a convergent sequence. So this all properties satisfied. Now what is the partial sum? If I take S1, what is that? It's a 1. S2, it will be 0. S3, it will be half. S4, 0 and so on. Fine. So it means Sk is equal to 0 for infinitely many k. Yes, it is in as infinitely many even numbers, it will be 0. So it is correct option. Sk will be greater than 0 for infinitely many k. Sk will be less than 0 for infinitely many k. For this counter example, it is not satisfied. But can this be true for other example? Because in this question they are not asking whether it's a true or wrong. Is it possible that xk is greater than 0 for all k? It is still not be there, so we will check about the another example. I can change the reverse part. What I can do, I can think about the sequence as of here. Again, I can simply reverse them. Firstly minus plus 1. Minus 1 by 4 plus 1 by 4 means I can simply change of this. Again it satisfies this property and this property. Then S1 will be 0, S1 will be 1, S2 will be 0, S3 will be half, S4 will be 0, S5 will be sum of this. So minus 1 by 3, S6 will be 0 and so on. Again for the even part it will be 0. Fine. So for the infinity this part is also satisfied. Sk is greater than 0 for infinitely many k. You can see there are two terms which are greater than 0. Rest are my less than 0. For some k, some is my also satisfied. Is it possible that xk will be greater than 0 for all k? How you can prove that it will be greater than 0 for all k? Okay, we will see. But is it possible that xk will be greater than 0 for all but a finite number of the values of the k? That's a very simple. We can think about any of the series, like any of the alternating series. Log of 2. Yes, log of alternating series, that's we have to think about minus of log 2. So what is the minus of log 2 is 1, minus 1 by 2, 1 by log 3, minus 1 by 4 and so on. Fine. So you can see this is nothing but my log of 2. It will be cancelled out. So the sum will be 0. It is convergent because log is a convergent. Absolute convergence is not be there. What is the S1? Is less than 0. S2, log of 2 is 0.3. S2 will be my positive. S3, this it's a positive, it's a 1 minus, it's my positive and so on. So is it possible for xk is greater than 0 for all but finite value of the k? This is a counter example. This is satisfied. Now, is it possible that xk is greater than 0 for all k? Can you think about that any of the term which is always be greater than 0? So we can rearrange them like of this 1 by 2, minus 1 by 2 and here. So look at that. S1 will be 1, S2 will be 3 by 2, S3 will be half, S4 will be my 0. So we need a not 0. So I can written as plus 1 by 3, minus 1 by 2 separate. So it will be 5 by 6 and so on. So you can define a sequence which is my positive for all are there. So this is also the right option. So all are my correct options. So therefore this A, B, C and D are my correct options. So as I discussed earlier, this example, it satisfied this property but not for this one. So that's why the right option is you have to consider certain examples. So I hope you can simply learn the various tricks from this lecture too. You can simply like, share and my comments on videos. Best of luck students. Happy learning.